Havika, experts for smooth running and directional stable vehicles. Presents the TA20 Wheel Alignment Training. In order to perform an axle measurement on the vehicle using the wheel alignment device TA20, preparatory measures are required. The vehicle must stand on even ground. The tire inflation pressure must be checked and the wheel caps must be removed. First, the turntables are positioned centrally in front of the front wheels. And are secured against rotation by use of the centering pin. The vehicle is driven slowly onto the turntables such that each wheel is positioned in the center of the turntable. Thereafter, the centering pins are removed. The track scale elements are removed from the tool trolley and plugged together. The laser measuring heads are removed from the tool trolley and plugged onto the assembly stand. In this way, the magnetic feet can easily be adapted to the required rim size. On both vehicle sides, one wheel alignment bracket each is fixed to the planar surface of the vehicle rim, with the laser head oriented centrally to the wheel hub. Both magnetic scales are attached on one vehicle side at the rear vehicle frame. Both magnetic scales are set to value 0 by use of the laser point. One of the magnetic scales is positioned at the same location on the opposite vehicle side. Also on this vehicle side, the laser beam is aimed to the center of the scale. Next, the steering wheel is turned until both magnet scales, left and right, indicate the same value. Now, the front wheels are lined up with the vehicle frame. In order to measure the total track value, an optical measuring triangle of a particular size and orientation must be defined by means of the track scales. This requires to first determine the rim diameter. The determined rim diameter is multiplied by factor 10, and thus yields the distance of the track scales relative to each other. The track scale positioned in front of and behind the axle is half the calculated value and is indicated on the ground by means of a marking. This procedure must be repeated on the other vehicle side. In order to establish the optical measuring triangle, both track scales are laid on the front marking and aligned lengthwise. Using the laser points, both track scales are successfully set to 0 on both sides, left and right. Now the said track scales must not be altered anymore with regard to length. In order to complete the optical measuring triangle, one of the track scales is positioned relative to the rear making. The two laser measuring heads are turned such that the left and right laser beams each focus on the rear track scale. The complete track scale must be moved laterally such that the laser point indicates the value 0 on one side. This completes the settings of the optical measuring triangle for the front axle. First scale value 0. Second scale value 0. Third scale value 0. The value now read from the fourth scale represents the total track value of the front axle. If the laser point points from 0 outwards, this indicates toe in of the axle. In this example, the value is 3.5 mm toe in. The read value is entered into the measurement protocol. If the determined actual value deviates from the target value, the value must be corrected by adjusting the track rod. A main cause for poor vehicle handling may be an incorrect steering wheel center position. In order to check correct alignment, both magnet scales of one vehicle side are set to 0, and then one of the magnet scales is transferred to the opposite vehicle side. Subsequently, the steering wheel is turned until both magnet scales indicate the same value on the left and right side. Now, the steered wheels are in position, straight driving, relative to the vehicle frame. In this steering wheel position, the marking for steering center position on the steering gear must be checked. If the setting is incorrect, it can be aligned by adjusting the thrust rod. Next, the camber value must be determined. For that purpose, the inclination angle indicator is attached to the measuring column of the axle measurement bracket. This inclination angle indicator is aligned as to show 0 in the plane parallel to the wheel. Next, the inclination angle indicator is turned by 90 degrees towards the rim for data logging. The indicated value is the camber value and must be entered into the measurement protocol. This procedure must be repeated on the opposite vehicle side. In order to measure the caster, the KPI, kingpin inclination, and the toe out on turns, it is required to use the 20-degree floor scales for the steer angle and to align these on the floor. The alignment is performed by means of the laser beam on the center line on the floor scale. Next, the steer angle is set to 20 degrees to the right side. It shall be ensured that the laser beam always points vertically onto the scale. The inclination angle sensor is turned and aligned to 0 in the plane parallel to the wheel. After alignment of the inclination angle indicator, the indicator is turned by 90 degrees toward the rim and 0 established in the display by pressing the Alt-0 key. Next, the steer angle is set to 20 degrees to the left side. It shall be ensured again that the laser beam always points vertically onto the scale. For easy checking of vertical alignment of the laser beam, the bubble level in the laser housing is used. The value now indicated in the display must be multiplied by a factor 1.5 to yield the caster value. When the Alt-0 key is pressed again in this position, the inclination angle indicator is turned by 90 degrees into the parallel plane. The value now indicated in the display must be multiplied by factor 1.5 to yield the KPI. The caster value and KPI are entered into the measurement protocol. In order to determine the value of the toe out on turns on the left vehicle side, it is required to turn the steering on the right-hand side as to indicate 20 degrees. In order now to read the toe-out value on the floor scale of the left vehicle side, it shall be ensured again that the laser beam always points vertically onto the scale. The determined value for toe-out on turns is entered in the measurement protocol. After completion of the measurements on both vehicle sides, the wheels must be turned back to position straight driving. In order to perform rear axle alignment, the short magnetic feet of the axle measurement bracket are replaced by the long magnetic feet. In this way, the axle measurement brackets can be perfectly attached to the planar surface of the rim, centered relative to the wheel hub. Also, for the rear axle, the optical measuring triangle is set up for the track scales. Both track scales are set to the same length with regards to one marking. One of the track scales is then positioned relative to the other marking and moved laterally such that the laser point aims at value 0.